Thank you. Hi everyone, I'm really glad to be here today. This is my third Tenji India, and give yourself an applause. You're an amazing audience. Thank you. Took that picture, right? I can say that people were applauding my talk now. Now, even if I fail, I won't be applauding yourself, of course. Okay. All right, let's get right into it. I'm going to be building a real-time bidding application, and that might sound confusing, so I'm just going to show you how it looks like. So this is the application. We have a couple of items, and this is something like eBay. You can go there and you can place different bids so that you can outbid the previous person who bidded money. And when I do that, you can see that the number here changes, and also the bidder name changed, because this is my fake username here. And what is more fascinating is that we have another browser in incognito tab, and the number here changed as well. I'll do that once again so you can see it. And you can see that we've got this real-time delivery of events. If I go here from the other browser and bid for the item, everyone who is on this page will receive the update. Amazing technology, like 2015. But what is more important about this application is that you can play it while you're listening to me. So if you get bored, you can just scan the QR code, you can bid yourself, and at the end of the talk, we can see who will have the highest number of bids and how many bids we've got. All right. So you can see that this is a very, very simple application, and because of that, I want to set some restrictions for how we will implement it, some objectives that we need to meet. We're going to have three different objectives. We want it to be cost effective. In fact, I don't want to pay anything for that application, not for compute time, not for storage, not for hosting. I want it to be completely free. Also, I want to have real-time delivery of events. I don't want to be refreshing the page to see who has the highest bid. And finally, I want to have straightforward setup. I want you, after this talk, to have enough knowledge and enough abilities to go ahead and basically rebuild the app in 1 hour and then spend 5 more hours styling it and making it beautiful. In fact, if you do that after the conference, you can find me either on Twitter or on LinkedIn, and if you share the source code for your implementation, I promise I will send you some very nice swag item from MongoDB. Remember that. All right. First objective, we want it to be cost effective. How are we going to achieve that? We will use two different systems. First, obviously, MongoDB Atlas, which is MongoDB's cloud platform. It allows you to host your database in the cloud. When you sign up, you get one free cluster with ½ GB of storage, which is more than sufficient for this demo application. You also get change streams. Now, what are these change streams? These are a MongoDB concept, or a database concept that is also implemented in MongoDB. They allow you to track real-time changes to your data, as these changes are written in the database operations log. So when you make inserts, updates, deletes to your data, these changes can be streamed back to you, and you can do something with them in your application. So basically, we are converting database operations to streams of events. And as Angular developers, we're more than capable to work with streams, either with RxJS, with RxAngular, or with now this new thing. All right, we will also use Atlas App Services. These are a sort of backend services that you can use for free if you sign up for Atlas. You get 1 million free requests, and it also allows you to send 10,000 concurrent requests, which is more than the people in this room, so we are safe there. We also have access to change streams. And I also mentioned that we will be using Firebase hosting. Firebase hosting provides us with some free storage, again, more than enough, free data transfer. It has some other nice, cool features that we get as part of the free tier, and of course we can pay for more if we want to. So let's let's see how we can make that work. First, I'll go ahead and create a new MongoDB database in MongoDB Atlas. So this is my Atlas project. I will go to build a database, and then I will go to the advanced configuration options so I can show you a bit more things. And then here we have three options. We have serverless, where you pay exactly for the operations that you execute. We've got dedicated, where you have some set of resources and some set of storage that you pay for every hour or every month. And finally, we also have the shared free tier that I mentioned will be more than enough for our use cases. So I will select shared. Next, we need to select the cloud provider and the region. I will use Google Cloud as a GD. I can use another one, but let's be nice to Google. And then here we can select a region that is close to us. In the paid tiers, we also have Delhi, but for the shared tier, the closest to us is Mumbai. Next here, we have the cluster tiers. Because we are on the shared one, we have M0. We have plenty of them. If you're more interested in MongoDB Atlas, you can take a look at all of the different tiers and features that they offer. In additional settings, we've got the MongoDB version, backup, and all that. And finally, we can select a cluster name. Now, when I click create a cluster, this will take 5 to 10 minutes to provision a cluster, and we don't have that time. But lucky for you, I have already pre-provisioned the cluster when I was sitting over here. And we have our bidding system cluster. Here I have different options. I can connect to the cluster. I can see some monitoring about it. We'll see in the end how many people are connected to our application. And I can also browse the existing collections. For those of you coming from SQL or tabular databases, collections are something like tables. And here we've got just a single database called auctions and a single collection called items. If we take a look here at our items, we will see that these are some good numbers. You're doing great. Keep going. So we've got the two items in our application that we saw. Our goal will be to connect our database to the application, so I can show you how it works. All right, now I'm going to switch over to this App Services tab. These are the Atlas App Services that I was talking about. Now we can see here that they already have a couple of different applications. This is sort of backend applications that I have configured. Let's create a new one, just to see how that works. I'll call that NG India. Then we need to link it to our data source, which can be our database. And that will be enough for now. By default, this backend application will be hosted in the region that is closest to our database, so that we have the minimum possible latency. All right, we've got plenty of things here in these app services. We will use just a couple of them. I will show you how to set up data access rules. Rules for who can access our data and what they can do with it. We can see here again the items collection, and we've got some presets. So we've got deny all access, read all, read and write all. I will select read and write all because we don't have time for authorization. Some other presets are, for example, users can read and write their own data, admins can read and write all data, or user can read all data but they can only write their own data. So there are some very useful presets that you can use if you want to. For now, we are doing the basic thing that you shouldn't do never. Like read and write all, anyone can do anything. But it's a demo, it's fine. And then I will also enable some authentication. We've got different authentication providers: email, password, Facebook, Google, API keys, JWT. For now, we will just enable anyone who opens the website to be able to sign in, to be able to connect to this backend service. So we're going to save that, finally review and deploy, and this is everything that we need to do for our backend. It's done. Now let's go back, or let's go for the first time, in our Angular application. Now I have prepared some code already here, so that we don't waste time for trivial things. So we've got this Realm app service. To connect to Atlas App Services, we're using a library called Realm Web. Don't worry about the naming. It doesn't make sense, I know, but that's the name. So for the Realm app, we can use the ID of our application that we just created to basically to be able to connect to it. So I'm going to define this static field here, and then in this getAppInstance method, I will either return the app if it already exists, or I will instantiate a new Realm application. Then I will create anonymous credentials, and finally I can use the app to log in. This is everything that we need for authentication. All right. Now we also have an auction service. And you can see here that I have already injected the Realm app service. So now we need to get access to our database and start showing some data. If I quickly go back to this application here, you can see that we don't need that anymore. We can see that this is localhost, and we've got some fake data here. So this is not the data from our database. So let's make it actually get real data. First, what I need to do is get the app from the Realm app service. Then I need to get a MongoDB client. We know that the current user is already logged in because this is how we implemented the getAppInstance method. So we can just get the Mongo client from here. And the Mongo client needs to accept this service name, which by default is MongoDB Atlas. And then we can get our collection. By using client DB, the database name was auctions, and the collection name was items. And finally, we just return the collection. We can also use TypeScript interfaces here, so we can cast this collection to auction. And that way, when we get items from this collection, they will be automatically casted to the auction interface. All right, let's load some items to display in the list. I'm going to get this collection from the method that we just implemented. And then I will use collection aggregate. This is an aggregation pipeline which accepts multiple stages, so we need an array, and I will have only one stage. I will use the $limit stage to provide a limit for how many items should be loaded from the database. I will save that, and just for a second I will show you the auction catalog component, where in the ng-only-init we just load the auctions from the auction service. That's very simple, and then we iterate with ng-for and we display them. Let's see if it works. Yep, we've got localhost, and we've got the ng-India t-shirt and the ng-India hoodie. Let's also implement the details page. So when I go to the auction, I can see the details and bid for that. It's pretty trivial. We can use find one. Again, we need the collection, and then here we need collection, find one. We need to search by ID, and here I need to cast the ID to an object ID type. When I save that, go back to the app and then navigate over here, you can see that now we've got this ng-India hoodie. We haven't implemented bid yet. So with bid, we will be sending an update operation to the database. So this is the bid method. I'm not going to bore you with any more live coding for now. So I'm just going to uncomment that. We are getting the collection again, and then we're using find one and update. This is an important method because it executes the whole command as a transaction, which is not the correct word when you're just updating one document, but it finds the document, it updates it, and it does that as one transaction. So when it's found and it's in that state, no one else can modify it while we're updating it. So we're finding the exact bit by ID, and then we are making sure that this is the current bit and this is the current bidder that we're trying to update. So that from the moment when we send this update to the moment when it goes to the database and checks if this is the exact same object, no one can go and change it. Then we're using increment to increment the current bit, and then we're using set to set the current bidder to some user. Sweet. I'm not going to show you the component. It is just a click event handler which calls this method. I'm just going to show you that when we go and bid and refresh, this changes. And this works, but you can see that it's not in real time. So we don't get the update without refreshing. This is what they mean by real time here. Which brings us to our second objective. How do we ensure real-time delivery? And what does real-time actually mean in this case? The term real-time is not very well defined because it can mean a lot of different things depending on who you're talking to. So if you have an airplane which has engines that are working and something happens and they need, the systems of the engine need to react in real time, this needs to happen in microseconds. This needs to happen immediately or you're gonna, I'm not gonna say it, but they need to happen very quickly. And these type of systems are very, very sensitive to latency. On the other hand, the real-time in web apps, the real-time that we're talking about, is not that sensitive to latency. We can react in milliseconds or in seconds. So basically real-time means that data comes to us without us having to do anything, and data comes to us when it's available. And to achieve that, we can use some managed cloud services. But what it means to have real-time data delivery in a web app? Usually it means that the server will be pushing data to our client application. We don't need to do a page refresh. And here are some examples of that. We may have a chat application, and when someone sends us a message, we should be able to see it delivered to us. We may have a stocks tracker, so when the price for a stock ticket changes, we should see that. We may have in-app notifications. We should receive these push events from the server. And finally, bidding apps is a very trivial example of that as well. So there are four main techniques to achieve that. We have these four things. We've got short polling, long polling, WebSockets, or server-sent events. And now I'm going to show you some diagrams and ask you to guess what are we looking at, which of these four we have. So in the first diagram, what we do is we send the HTTP request to the server. We wait, the server waits until there is new data available and sends us a response. Then we immediately send a new request. The server doesn't respond immediately. It waits until new data is available and it sends a response to the client. So is that short polling, long polling? What is that? Yeah, that's long polling. Good job. All right, in the other example, we've got request response. The response may be no data or there is data. Then we wait for some very short period of time. We make a request again and the server responds either with the new data or it says no data. Then we wait and then we repeat that every half second. What is that? Yes, that is short polling. And the problem with that, as you can guess, is that we are constantly sending requests, so we might overload the server. And there's a bunch of traffic that goes constantly. With this example, this technique, what we do initially is we do a handshaking using HTTP. Then we open a TCP connection, which allows us to have a full duplex communication, which means that we can have bidirectional communication, so the server can send data and the client can also send data to the server. And finally, when we don't need that anymore, one of the two sites can close the connection. Which technique is that? Yep, that's WebSockets. Perfect. And the last protocol, which works just with simple HTTP connections, does the following. We open an event stream, then we open a long-lived HTTP connection using a special MIME type and with keep alive, and then we have simplex communication. Simplex means, as opposed to duplex, that the server can only send events or data to the client. The client can't send data. And we terminate that by closing the connection. And what is this one? Yeah, you don't know. That's good. I can show you something new then. So server sent events. This is a more or less known protocol, but it's still very similar to WebSockets. Let's see what are the differences. We mentioned already, with WebSockets we have bidirectional communication. With server sent events we have communication only from the server to the client, only one-way data stream. WebSockets work using the WebSocket protocol, and then they open a long-lived TCP connection. Server sent events work only by using HTTP. It can be HTTP 1.1 or HTTP 2. There are some differences depending on the limitations that these two protocols give you, but you can still work with HTTP 1 with server sent events. Other difference is that WebSockets can transmit binary data and UTF-8, and server sent events can only transmit UTF-8. There are some problems with WebSockets when you're using a corporate firewall, and maybe server sent events can be an alternative in that case. In terms of, is that usable today? Yes, it is. Both are. So WebSockets are supported by 98.3 whatever percent of users and browsers globally around the world, so basically everyone supports them. Server sent events are supported by 97.94%, so pretty much the same if we don't count Internet Explorer. So which one should we use? Well, it depends on your use case. If you need data only from the server, then server sent events. If you need two-way communication, WebSockets. But we also want to have straightforward setup. That's why we will use some cloud services. There are a few different ways to implement that using a cloud service. AWS AppSync is one of the most popular ones. We've got Confluent Cloud as well. If you are a fan of Kafka, that's probably what you are going to be looking for. And I already showed you MongoDB Atlas. And I'll show you how to use server sent events under the hood to receive real-time data changes. Let's see how that works. Sweet. So we're going to get our collection again here in this get collection watcher method. And then we are going to get a watcher by calling collection.watch. And here we can provide different things. I want to only be watching the IDs of the items that I see on the page. So I can provide IDs here. But again, the IDs should be of the object ID type. So let's map them quickly to an object ID. And now we've got a watcher which is of type async generator. And we can use the from operator from RxJS to convert that to an observable. We should also extract exactly the information that we need here. So I'm going to use filter. First, I will filter only update events. So only events that happen when someone updates the bidding price. So we've got our event, and here I have a helper method that is called isUpdateEvent. And then I will also extract some data from the event using map. I want the event ID, which lives in documentkey.id, and I also want to get the update description. All right, that should be enough. I'm using this watcher in a very trivial way in the auction details component. Let's see the auction details. So here we get this watcher, and we subscribe to it, and then we just update the auction when we get an update. Sweet, let's see if that works. So I am now clicking the button and it actually updates this price automatically, which is nice, it works, but we have a slight problem. And let me show you what I mean by that. So I'm gonna go to the network tab and now refresh this page. And here, so these are all events. I will filter only the fetch and XHR events. And you can see here that this is our long-lived connection. It is still open. It hasn't finished because it is long-lived. And if I go back to the auctions list, we will open a new connection. And now if I go back to the auction, we should be able to see that connection here. And we see that the connection is not finished yet. Let's go back here. Now you see also another connection that is from the details list. And you can see here, if you watch very carefully, that we open a new one. And now if I go to auction, we will see that this is also still running. So that's not very optimal, is it? By default, we can open 6 connections per browser, per domain in HTTP 1.1 for server-sent events and 100 for HTTP 2, but still it's not very good to keep these connections open if we're not using them and recreate them on every page navigation. So let's go ahead and see how we can fix that. We need to basically somehow stop this watcher when we navigate away from the page. To do that, I need to call watcher.return. But I can't call it here because we're just going to close the stream immediately. So I created this custom RxJS operator, very fancy, which takes the source. It creates a new observable, which does exactly the same things that the other observables in the world do, which is very simple. We've got next, which calls subscriber next, we got error, calls subscriber error, complete, trivial. The only difference that we've got is that here we call source.return and we stop the watcher. Very ugly API, but this is how it looks like. So basically when we say unsubscribe for this, from this observable, for this subscription, this is going to be called and it will also stop the connection that we've got. Let's see if it works. So we've got from change event. Instead of from here, I will use from change event. Let's save that. And I will just refresh that once again. So we've got our connection here. You can see it. It's not finished yet. And if I go back to the list, we should be able to see that it's now finished. I refreshed the page, so that wasn't optimal. Okay, this one should be finished now. And you can see that we don't have this connection is still open or whatever. This one is still open, and if we go back, we should see that it's now closed. So it works. This is good. A more optimal way to implement that is to reuse these connections based on the IDs that you're passing in. So you can think about that when you implement it yourself. Again, you can send the code later. I will send you something in return. But yeah, let's go back here. We did a lot of nice things. If you're interested in MongoDB or MongoDB Atlas, you can scan this QR code. I have a couple of my colleagues here as well. If you want to speak about what you saw today, you can find me or them. And thank you for your attention.